Hey guys, so recently I'm sure you've seen the new OpenAI image generation model that's really powerful. A lot of people have been talking about it. I'm sure you've seen the videos of people converting their selfies or just images in general to Studio Ghibli style images. It's just a really powerful model overall, and recently they actually just added it to their API, so you can actually use it programmatically in your applications. So in this video, I'll be showing you guys how to get started with it, how to use it, and then at the end of the video, we're going to make a recipe application so that we can create recipes that has images in it. It's going to look really cool. So feel free to skip around to whatever part you want to watch, but overall if you're excited to see any of that, then keep watching. So here's the image generation guide on OpenAI docs. It's actually pretty good, so take a look at it. I'll leave a link in the description below. They describe how you can use the image API or the responses API to do stuff like generating images, editing images, or generating variations of images. The image API is useful if you want to directly work only with images, so generating and stuff like that. If you've ever used this is the newer API that you can use to actually work with the GPT to get responses back from, GPT 4.1 or 4.0 or stuff like that. So what you can actually do is use these image models as a built-in tool of the large language model that you're interacting with. So basically, you can have a multi-turn conversation with the GPT, and then you could say something like, generate an image of a potato, and it could just do that automatically in the conversation. So this one supports only image stuff, but this one allows you to do stuff while in a conversation. So this one's a little more flexible, but you can use either approach, whatever you're trying to do. So in terms of the models that you can actually use, the newest one that we're talking about here is GPT Image 1. At the time of recording, that's the most powerful version of the model that they offer that has all the new stuff that you've seen recently. So it says superior instruction following, text rendering, detailed editing, and real world knowledge. And then you have the older models, DALL-E 2 and DALL-E 3. These are pretty good, but not as good as the new one, of course. So they have a bunch of code samples here using both the responses API and the image API, so make sure to check this out. I'll show you some code examples real quick. So we can make our OpenAI client. It's automatically going to fetch my OpenAI key in the background. It's an environmental variable. And then after that, we're going to use the image API that we talked about to generate an image. So we're simply doing client.images to target the image API and then generate. It's really simple. So we give a prompt, a tuxedo cat with a mustache, only half a mustache. He is playing with a toy mouse. This is my cat, Mr. Beans. We're going to specifically target the model GPT Image 1, the newest one I told you about, and then we're going to specify the size of 1024 by 1536. I'll explain that in a second. And then also we're going to do a quality of just low. So from the result, we're going to get the data as a base64 JSON string, and then we're going to decode that into raw bytes. So like I said, just raw data, and then we're going to save that raw data into a image file called mrbeans.png. The default response for these generated images is PNG, but you can specify other formats if you want to, like JPEG or WebP, I believe. And now the last thing that we're going to do is use the display function and basically read from the file that we just wrote and just display it in the notebook so we can see it. So let's try it out. Here it is. This looks actually a lot like my cat. So we have a cat here with a mouse, a toy mouse, and he has half a mustache. Very cool. So here's some of the things that you can provide to it, like the size. So it's very limited in terms of what size you can output for these images here. So you can either do a square picture, so 1024 by 1024, landscape, or portrait. So you can choose amongst those three. And then for the quality of the image, you can do low, medium, or high. There's some other settings, but those are probably the most important ones. What's really cool about this is that not only can you generate images, you can edit images. It's a very powerful feature. So if I display this image I have in my images folder, very beautiful, very bald. His head is a little shiny for my taste, so let's get him a nice head of hair. So all we gotta do is come up with a prompt, give this gentleman a nice swaggy fade haircut, no more baldness. Sounds good to me. So instead of client.images.generate, it's client.images.edit, very intuitive. Pass in the model name, pass in the image that we want to reference. So you can actually give it a list of images, so as many as you want pretty much, and then it can generate an image based on the image that you provided. So very powerful feature. So again, we're going to extract the raw data from the output and then save it to a PNG file and then open it to display it. So let's try it out, see if we can give the rock some hair. There we go, he's got some hair now. It looks beautiful, looks like Ronaldo now, kind of. So yeah, you can use the new images API with the new model rather to edit images. Very powerful. Play with that, have some fun with it. It's very cool. Now I told you before that if you're familiar with the responses API, which is something that you would normally use to just talk to ChatGPT regular, so just for text messages, basically, you can actually still use the image generation model with it. So we're still specifying GPT 4.1 mini, or you can do 4.1, I believe. And what's cool about this is that you can specify image generation as a tool. So if you don't know, a tool is just a thing that the model can choose to invoke to do something. So what it can do is if it decides to use that tool, it will use the image GPT image 1 model automatically, like we did above, basically to do image generation. So for example, if my message is just "Hey, how are you?" it's going to want to respond with text. Obviously, that's not anything to do with generating images. But if I was to say something like "Hey, how are you?" make an image that describes your mood, this would be an obvious situation where it would invoke the image generation tool to then invoke the GPT image 1 model to generate an image. So this piece of code here will basically just process the output from this response here. So it's going to check the output, check to see the type of the output. If it's a image generation call, it's going to automatically extract the image data, save it as a file, and then show it same as before. And then if it's just a normal message, it'll just display the message to the output. So let's try it out. There we go. It's very fast because it's not doing any image generation. So it says, "I'm doing great, thank you. How about you? How can I assist you today?" So now let's change it to this. Make an image that describes your mood. Let's see what it gives us. Here we go. So we got this really beautiful picture of a lake with looks like kind of a sunset or a sunrise. "I'm feeling serene and calm, like this peaceful sunrise over a misty lake. How can I assist you today?" That is really, really cool. And I actually tested this before, of course, before I started recording, and it gave me a different image. So that's interesting as well. So here's all the supported models. If you want to use the responses API, you have GPT 4.0, 4.0 mini, 4.1, 4.1 mini, 4.1 nano, and O3. So basically all the top line models that OpenAI offers currently at the time of recording. So in terms of cost and latency, so here's the details on it. So it depends on both the quality and the size of the image that you do. That kind of makes sense. So you have to find, based on which settings you have selected, the amount of tokens that you have used, and then you can then calculate the input tokens and I guess the output tokens for the image that you're trying to generate. But now, real quick, I want to show you guys something really cool, which is how to build a cool recipe generation app. Because I don't know about you guys, but every time I'm trying to, find a recipe online, like especially on my phone, it's just a really horrible experience. It's really painful overall. Because you go to this website, right? And it's basically like a blog. It's got a million ads, first of all. It's horrible. It bombards you with ads. It's especially horrible on mobile because you gotta click the little X. This one's not too bad, but usually they're pretty horrible. And then not only that, before you even get to the main recipe itself, you got this whole backstory about why spaghetti changed her life and why spaghetti is so beautiful. I just want to get the recipe. So I'm just going to skip down and, this is the main part you want. You want the ingredients and then you want how to actually do it. And it's got images as well. We're going to make a little app that can basically take a food idea, such as Italian sausage spaghetti, and it's going to automatically generate the ingredients, the steps, and then also generate images based on what we just learned. So let's see how we can do that. So to do this, we're going to use a Streamlit application. If you're not familiar, it's just a basic Python front-end kind of library thing that you can use to make websites really easily. So using Python code, you can basically make a website. It's really cool, especially for little demo applications like we're trying to do here. So this code just gives the page a title and a description, and then a little form where you can put the recipe that you want to make. So let me show you what it looks like. So to run this, all you got to do is go to your console and do Streamlit run and then the name of the file, so app.py, and just make sure that you have Streamlit installed as one of your packages. So do that, and then it's going to automatically open the page in your browser. Here it is. So recipe generator with step-by-step AI images. Describe a dish you want to make, and this app will generate a full recipe and step-by-step images using AI. So I'll do spaghetti and meatballs, and we'll generate a recipe. So obviously I haven't hooked anything up yet. Let's do that now. So what we want to do is take the text that was put into the input box and use that to generate a recipe using GPT. Let's start by making a function that we could do that with. So define generate recipe, and we're going to use that. We'll do that based on user input. So it's a string, and then we'll pass in our OpenAI client. So OpenAI, like that. Let's define a recipe. So we're going to do class recipe. It's going to be a base model. I'll show you why in a second. And our recipe is going to have three things: a title, and then also a list of ingredients, which can just be a list of strings. And then after that, we want the actual steps of the recipe. So that's going to be another list of strings. And now what we want to do is use the OpenAI client and invoke GPT 4.1 to get a recipe. And what's really cool is that it has a structured outputs feature so that you can get the response directly as this type here recipe instead of as a string message. So here's the prompt. You are a helpful chef AI. Generate a recipe for the user. Respond in the following JSON structure: title, ingredients, and then the steps. So you don't actually have to tell it to respond in this structure, but sometimes it helps for reliability. So you can remove it if you want to. Because we specified here text format recipe, it's smart enough to know that it has to return it as this specific format. And then it'll automatically parse it and then give it to us as this type. So we can do return response.output parsed. So instead of output text, output parse to get it as this type here. And then here's the next part here. It looks complicated, but it's pretty simple. So if they've submitted the form, so they type something in, they click the submit button, it's going to say you want to make and then confirm what they typed in, and then say generating recipe with GPT 4.1. And it's going to show a little spinner icon while we're waiting, because this will obviously take a second to generate. So what it's going to do is first call our generate recipe function that we created. So it's going to invoke our GPT 4.1 model with the prompt here, and then also with the user input. So spaghetti and meatballs, for example, and this can return it as a recipe type. So now we'll go back, and then based on the recipe type, we're going to print out the title as a header or subheader, and then we're going to print out in Markdown the ingredients list as well as the steps. So it's really that simple. It looks complicated, but it's not. So now we'll come back to our code here, and then at the top here, you can click rerun, and let's try this again. Hey, there we go. We have a full recipe now. So we can see our title it came up with, pretty simple. Ingredients, there's a lot of them here, very detailed, but it looks good. And then we have our steps. So in a large bowl, mix together the breadcrumbs and the milk. Oh, this is not. Oh, okay. So we're making the meatballs from scratch. That makes sense. We're not just buying frozen meatballs or nothing. So you can read through that if you want to. But overall, it looks good. This is what we want. So now let's get to the cool part, which is generating images for. Well, basically, we want an overall image. So an image that just shows the end result of the recipe. I think that's what you would expect on a recipe website, as well as the step-by-step images. So for example, if it's showing you making meatballs, it shows a picture of meatballs before they're put into the oven. And then if you're showing, chopping onions, then it would show a picture of you chopping onions, for example. So to get the images for each step, we're going to make it so that instead of returning a list of strings for the steps, we return a list of a new type. So this is just going to be called a type recipe step. And this will also be a base model from Pydantic. Now each step is going to have an instruction and then also a image prompt, which can be optional. So it's going to be an optional string. And then we can replace our original string type with recipe step. So the idea is we're going to let the large language model that generates the recipe decide the prompt for each of the steps. And it's going to be optional because we're going to tell it to not generate a image prompt if it doesn't seem useful. So if it's just like turn the oven on, that's not very useful, obviously. So it can choose whether to provide an image prompt. And if there is one provided, we'll use that to generate an image. And this is, I think, a good approach. There's different ways you could do it. Another way is like, for every single step, then you go off and come up with a prompt and then you get the image from that. That can be effective if you do it well, but I think this is a better approach just because you're giving the GPT who's actually coming up with the recipe the power to come up with the images themselves. So since it's coming up with the whole recipe and knows the recipe, it can give you better image prompts in general. And overall, it just simplifies things. So we've got an updated prompt here. So your helpful chef AI, create a recipe for the user. For each step, also provide a concise, vivid image generation prompt describing what should be shown for that step, but only include an image prompt if a visual would be genuinely helpful for that step. If a step is purely textual or does not provide any benefit from an image, omit the image prompt from that step for that step. Now, to get an actual image from a prompt, we're going to make this function here. It's called generate image. Takes in a prompt, takes in the client, returns bytes, which is the raw data of the image. So again, we're just calling client.images.generate, specifying the new GPT image 1 model, giving it the prompt, giving it a size. You can customize it if you want to. We can set that to high if we want to. Here's the final code using the functions that we now have. So first we're going to generate the recipe, same as before. And then the first thing that we do is before showing the ingredients and everything like that, we're going to start generating a finished product image. So we're going to have the image at the top. And then for each step, we're going to have different images, right? So this will be the image at the top that shows the final result given the title of the recipe. So the prompt for that will be a beautiful appetizing photo of the finished dish, and then the name of the dish, and then the ingredients. That's also helpful. And then we define the styling of the image. So professional food photography, well lit, and with high resolution. So I think that's good. And once we're done generating it, we're going to get the bytes and then display them onto the page. After that, we're going to display the ingredients on the page. And then now for each of the steps, this is kind of a little tricky looking, but basically it's just using a concurrent thread to generate all the images at once. It's just going to call the generate image function that we made in parallel to make it faster. So for each of the steps, if there's an image prompt for that step, we're going to generate an image for that step. And then finally, once we're done generating all the images for all the steps, we're going to display all those steps with their images if there are any. So hopefully that makes sense. Let's take a look at what it looks like now. Let's do spaghetti meatballs again, see what we get. All right, here we go. So we got our nice picture of spaghetti meatballs. Looks pretty good. So let's see how to create it. Here's our ingredients. Here's the steps. So in a large bowl, mix ground beef, breadcrumbs, parmesan, blah, blah, blah. That looks pretty good. Looks accurate. Form the mixture into small meatballs about the size of a golf ball. Looks good. Heat olive oil in a large skillet. Brown the meatballs on all sides. Looks good. It even has the browning. Very, very nice. In the same skillet, add chopped onion and cook until soft about 5 minutes. It looks good. Return the brown meatballs to the skillet with the sauce. Looks good. and then here's the final product again. So, damn, I think this is really impressive. I really like this a lot. Let me try another recipe. I'm gonna try something totally random like blue milk from Star Wars. Let's try that, see what it gives us. All right, let's check it out. So we got our blue milk. Looks blue milk. Here's the ingredients: some whole milk, coconut milk, sugar, vanilla, blue food coloring, and ice. Okay, combine the whole milk, coconut milk, sugar, and vanilla extract into a blender. Even gives us labels. That's kind of cool. Add a few drops of blue food coloring, and then blend the mixture until fully combined and slightly frothy. This looks really cool, really good, honestly. Pour the blue milk into glasses over ice if desired. Serve chilled and enjoy your Star Wars blue milk. And it gave us, wow, that's actually kind of cool. It gave it to us in a Star Wars sort of setting. I don't know about you guys, but I think this is really cool. This is only the first, version of this new GPT image model. It's obviously very powerful, so I can't wait to see what they have next. But yeah, I just hate recipe websites, so I think I'm gonna start using this more often now to get recipes for myself. It seems to do actually really well, so you just have to trust that it knows the correct measurements for the ingredients and everything like that. But that'll get better over time, of course, with better models. But that's pretty much it. That's all I want to show you guys. That's how you can use the new GPT Image 1 model from OpenAI using the Image API and also the Responses API. So hopefully you guys found this video interesting, and please let me know what else you guys want to see. All right, peace.